Thank you all for coming to this lighting talk. It's our great honor to have been selected. And then today I'm very excited to share this image, celebrating more Starry Night, more life shine bright. Oh. So this image shows a fallopian tube tissue section from a patient with BRCA2 mutations. Women with BRCA mutation have much higher lifetime risk, with up to 40% developing ovarian cancer. However, ovarian cancer is not limited to high-risk group. It also occurs in the general populations, where about 1 in 78 women will develop this cancer. The fallopian tube epithelium is a known origin of ovarian cancer. High-grade serous ovarian cancer is the most common and lethal subtype. This cancer usually develops through a precursor lesion called STIC. Initially start with a TP53 mutations. It progresses and spread to the ovary and form tumors. Here show a real fallopian tube specimen that was collected after surgery and shipped from our close collaborator at Johns Hopkins Hospital. People usually use the C-film protocol to search for potential STIC lesions. Pathologists cut fallopian tube into tiny pieces. Then they examine hundreds of slides on the microscope to look for tiny STIC lesion by eye. This process is very dedicated and time-consuming because STIC lesion can be extremely small, sometimes less than 1 to 2 millimeters. So some early lesion may still be missed during routine screening. The difficulty in detecting early STIC is just one of the reasons that make this cancer so deadly. Most patients are diagnosed at very late stage because the early change in fallopian tube is usually silent. We also lack of efficient screening tool. Imaging method like MRI or ultrasound cannot detect tiny precursor lesions. So all of these reasons highlight a critical need. We need to study this disease earlier and develop a new detection method for better prevention. In the Belcher lab, we always focus on developing a novel imaging technique for early detection and prevention, such as this OverSeq system that can scan the entire fallopian tube tissue. Building on our previous imaging effort, we are now advancing to a new high-resolution label-free imaging system. These systems enable image of live cells, tissue slices, and organoid sections without staining or labeling. So using this setup, we build our own unique biological optical data set and train an AI model to analyze these images, detecting cellular mutations, abnormal lesions, and other cancer-like behavior. The selected images were captured using our label-free imaging system. So the blue and green color you see are generated by our AI analysis, which the color gradient show the intrinsic optical properties of the tissue, such as intracellular mass density and the structural organization of the fallopian tube. So we hope this AI label-free imaging platform can accelerate doctors and pathologists' screening time and narrow down the focus region to find STIC earlier and quickly. So we are also designing and training our own transformer model, and we are currently fabricating a digital chip to support this platform. So in the future, we aim to detect mutations and abnormal lesions in real time from patient cells, tissue slices, biopsies, pap smear, etc., for better clinical translation. So our model now can achieve an average accuracy of 95% in mutation detections, and we are continuously refining and expanding it to include more mutations, additional cancer type, and more sample types. So beyond the real-time mutation and lesion detection, we are also developing an AI level-free imaging platform to detect and predict drug response, which could help with personalized cancer therapy and also decision-making. So we hope to use this platform to predict the potential drug responder in a faster timeline. So coming back to these images, we named it Celebrating More Starry Night, More Life Shine Bright, inspired by Van Gogh's beautiful Starry Night. So we are seeking the potential solution for early cancer detection and preventions. Using the AI label-free imaging platform, we aim to detect mutation-specific changes and abnormal precancer lesions on the patient tissue slice like this. So we hope to bring more Starry Night, helping more patients' lives shine brightly in their own sky. In the end, I would like to thank all our patients and sample donor, as well as Great Foundation for their support to make this project possible and meaningful. I also like to thank KI Imager Work Committee for their selecting our work. And I also deeply grateful to my advisor Angie, the Belcher Lab members, my Europes, and all our collaborators whose continuous effort to make this project moving forward. Thank you all for listening.